to the quadruple of their product, find A minus B divided by A plus B. This equation I already solved in previous videos. I will not do it anymore. Please just check back. Thanks for understanding. But the answer was D here. So go to question number 5. For question number 5, you were told that alpha, beta, minus I are cube roots of I. Find alpha squared plus beta squared. So for a cube root of a number, for example, 2 is a cube root of 8. That means 2 to the power 3 is equal to 8. So if 2 is equal to the cube root of 8, that means 2 to the power 3 is equal to 8. So we'll try to use the same idea here. Let's assume that this is z, then means z cube is equal to I. Because z is a cube root of I. So I can write it in the form z cube minus I is equal to 0. I can fix this and write it as z cube plus I cube is equal to 0. You were told that I was equal to square root of minus 1. So that means I squared is equal to minus 1. So I cube is equal to minus I. So it's the same thing here. So I replace the minus I there with I cube. We already know that minus I is a factor. So that means z plus, so this is a root. That means z plus I will be a factor. So I will try then to factorize this. You would have already learned how to factorize the sum of two cubes. So if I have a cube plus b cube, the factors will be a plus b into bracket a cube a squared minus ab plus b squared. Or the difference of two cubes, this will be a minus b into a squared plus ab plus b squared. You can actually check that that is true. Yeah, if you take this a times this is a cube, a times that is a squared b, a times that is ab squared. If you take this, this is a squared b, cancels away, this goes cancels away, and then you are left with the last one there. So if that is true, we will use the first one to factorize this. That means my z cube plus I cube can be written in the form z plus I into bracket z squared minus I z plus I squared. I just use what we have here. I squared is minus 1. So this is z plus I z cube squared, excuse me, minus I z minus 1. There is something that you also learned in the past. So since this is already one root here, the remaining two should be alpha and beta. So the alpha and beta should be the roots of this remaining part. We already learned in many other videos that are within the YouTube channel for the Math Salon that if I'm given two roots, alpha and beta, then I can actually build the equation. That equation will be of the form x squared minus alpha plus beta, x plus alpha beta is equal to 0. So I'm just left to compare these two here and see how it goes. So I can write this. So this in this form means my z here squared minus I z. So I'll write this with a plus. So I'll just write plus and put minus 1 in brackets. If I do this, then I say that my sum of root is simply I and the product of root is minus 1. So sum of roots is equal to I and product of root is equal to minus 1. To get this now, I need to use this information, but it's not in that form. So I'll play with it. So I know that alpha plus beta squared is alpha squared plus beta squared plus 2 alpha beta. I'm looking for this one, so I can take this to the other side. That means alpha plus beta squared minus 2 alpha beta is equal to alpha squared plus beta squared. I have all the information I need from here. So this here, this is I squared minus 2 into minus 1. That's alpha squared plus beta squared. I squared is minus 1. Minus 2 times minus 1 is plus 2. So this is equal to 1. So the answer for that was 1. And I think that was C. So you have to choose C. Let's look at the next question. You have to find the number of factors that this. has x to the power 8 minus 1. You can always play with it to get the idea of difference of two squares. So this is x to the power 8 minus 1. This is also like 1 to the power 8. So I can split this one as the difference of two squares. This x to the power 4 minus 1, x to the power 4 plus 1. I can do this power in difference of two squares on this again. This becomes x to the power 2 minus 1, x to the power 2 plus 1 times x to the power 4 plus 1. I can do it again on that. So then I have here this x to the power 8 minus 1 becomes x minus 1, x plus 1, x squared plus 1, x to the power 4 plus 1. You would think that 4 was the correct one. That is not sufficient. So we still have to play with this here. We'll play a small trick there. What we do is that I'll write all this that you have here, minus 1, x plus 1, x squared plus 1. And for this, I would put x to the power 4 plus 2 x squared minus 2x squared plus 1. Because I can actually have natural powers of x, but the coefficients could be surds. That's not a problem. The only problem is you cannot have a root, otherwise then it's not a polynomial. So if I do this, then I've added and removed it, so not to change it mathematically, but I can shift it a little here. Then I get x minus 1, x plus 1, x squared plus 1. I'll write this as x to the power 4 plus 2x squared. I shift this one plus 1 minus 2x squared. If you check this, this can be factorized. This is x squared plus 1, all that squared. So this is here x minus 1, x plus 1, x squared plus 1, x squared plus 1 squared minus 2x squared. You see, it's a difference of two squares again. So then I have here x minus 1, x plus 1, x squared plus 1 into x squared plus 1. I would play with this. This is also like root 2, all that squared, root 2x. So this will be here plus root 2 x, x squared plus 1 minus root 2 x. The root 2 is outside, so the x is not under the root. So there were 5 of them. There were 5, and 5 was number, that was D. The answer for that one was D. So we had this exponential equation to solve. The key thing here you would have learned is you have to try to recognize, bases that you can play with. For example, 2/3, I can see that 2/3 can also be played here because this is 2 squared, that's 3 squared. So I can write this as 3 here, 3 on 4 to the power 2t, because it's squared, the square multiplies this and get that, minus 6, 3, 2 on 3. Oh, what am I saying? 2 on 3 to the power t plus 2 is equal to, I can also play with this one here. The power is only to the 2, not to the minus. So the minus can stay outside and I get here, this is 2t divided by 2 over 3t times 3. If you play with this well here, this is 2 to the power t, the 2 comes down. So I get here minus 2 to the power t divided by 2 times 3, 3 to the power t. This 3 comes in front and joins with this 2 there. And this gives me minus 1 over 6, 2 to the t, all over 3 to the t. And I can play with it. Since all of them have the same powers, I can actually remove it and put outside. Then I can say, because this looks a bit messy, I can take it to the salon and make it a little beautiful. That's what we are doing here. So I can say let 2 on 3 be equal to p. Then this equation will be nice. It will be 3p squared minus 6p plus 2 is equal to minus 1 all over 6p. Can multiply all through by 6 to make it look nice. Then I'm going to get 18p squared minus 36p plus 12 is equal to minus p. If I take p to that side to make it neat, I have 18 p squared minus 35 p plus 12 is equal to 0. This is a quadratic equation in p that I can solve. I can also use factorization. You can use any method that you want to solve that. You can use the quadratic equation formula, look for the discriminant, and apply all the techniques. But it's easy. I can factorize it here. So 18 p squared minus 35 p plus 12 is equal to 0. Okay, 2p here, 9p. I factorize this in such a way that when I cross multiply, I should get a middle term. So I can get a minus 4, minus 3. So that minus 4 times 9, no, I think it's the other way around. It doesn't give me. So I get a minus 3, minus 4. So the minus 3 times this is minus 3.